Right. You are ready there.
Yes.
Okay. Let's start. Welcome to Coxygen Global. We are going to do the technical documentation and the user documentation on English auction, which was created using Helios Coxylib. So what I need you to do is to follow with me first on this one here. So I'll open this site, we'll run through it together and see this thing here. Right. Let me first run it as a user. If you remember the last diagram, this one here. Okay. I said this is how the app works. There is the off-chain code, deadline, mini bid, 1 NFT. We refund the bidders, and then we log the highest bid to the smart contract. What you see there, this box here, where there is numbers 3, 4, 5, and there's an NFT. This is the smart contract. And this smart contract has a deadline. So I want you to look at those things here. So your user documentation must have these features. Number one, the first user is going to start the auction, going to put the NFT plus 3 Ether onto the smart contract. It can be 1 Ether, depending on your minimum, your start price. And from there, anyone, either B, C, D, they can come in now and bid. And then their bid must be higher than the previous bid. Their bid is the same as the previous bid, like you see it is bidding for Ether. And bid first for Ether. So B first needed, because bid is what? Smaller. It's equal to the one that is already there. C is 5 Ether. So C bid is better. Let us test this functionality together. So I'm going to start. I have already an auction that is running. So how am I going to close this auction? It is already running. The app now is working, but still we are going to find some bugs. So let us have a roadmap to test it. Right, number one, let's start auction, which means someone must start the auction. And then when we start the auction, we are going to start it with 1 Ether. And then what are we going to do? We are going to log 1 NFT to a smart contract. We are also going to log that 1 Ether to a smart contract, so that now the smart contract is available to other bidders. That NFT is a minimum price. Okay, so the minimum price we said is going to be 1 Ether. So let me check. What is it that I left out? Deadline. Yeah. When you start this, you need to indicate the deadline. When do you want this to stop? Okay. Set deadline. Who is going to start the auction? We call that person owner, auction owner. The one who starts becomes the auction owner. He is the first person to start the auction, so he's the owner. In this, we are going to identify people with pub key hashes. What else do we need for the auction? To start. So number one, we start the auction. Did I leave anything out? If I left something out, we will come back. There is no previous bidder when you start, so the auction doesn't exist. So the other things that are very important when you start the auction is you need a script. There must be a script address created. There is a script for the smart contract. We call it a validator script instead. But there is no script address. So when you run this for the first time, you'll need the script address. What is the script address for? Did you get my question?
You said, what is the script address for?
You can't answer that. If there is no script address, then where are you going to log your NFT for other people to find it online on the blockchain? Where are you going to log it? So you need the script address on chain so that you log the header, you log the NFT. Then you can go away. And any other person can come to the app. First thing before they bid, they want to know what am I bidding for? NFT. They see the details of the NFT. How much? Any amount, but what is the minimum that is already there? The minimum bid here must be displayed to the new bidders so that they know they have to bid higher. If I leave anything else, let me know. So I'm trying to help you. This will help you with the documentation. So the reason for we need the script address, we need it to discover the auction where it is on the blockchain. If we do not have the script address, I want you to see the problem we are going to have. Here, I have got the Explorer blockchain. That link has a script address. But now, if you come to the blockchain, here's the blockchain. This Explorer is showing us the Cardano blockchain. Lots of things are happening there. But how are you going to discover your smart contract for auction? The only way you can find that auction, you need an address of the script that is on the blockchain. That is the purpose of what I've given you. That is what you need to explain on your documentation. Is it very clear?
Can you please repeat, sir?
Right. First, my question was, what is the purpose of the script address?
And the answer was it is needed it is needed on chain so that you can lock the header.
Yes, not only header, also to log the NFT that you are auctioning. Do you get that?
Yeah.
Yeah. The third reason, let's write these reasons down because definitely they are going to help you. So the first thing, log header is there, log NFT is there. Discover the auction smart contract on the blockchain. If you do not have the script address, then you will never find the smart contract. Like here, you see what I'm showing you here? This is the Explorer showing us the blockchain. How do you find the smart contract without an address? You need that script address. Okay, I will show you when we are using it. Now let's come to this one here. You see this link that I'm giving you. I think we should also explain things with some links. Here, you see this one has a smart address. So we can find the smart contract using that script address. This script address, let's look at it. See, there it is. This is the address. There it is. If you go, you click the UTXO, you can see there are 2 bids that have been done already. See, this was the first bid. But I'm able to see the bids of the previous people. Why? Because I've got address. This one has no address, no script address. That is why without script address, like this, you cannot, no one, it is impossible to find the smart auction smart contract, or in a simple way to find the auction on the blockchain. Okay. When we say find the blockchain, we are referring to the smart contract. Any question?
No questions so far.
Right, let us check this one, analyze this one here. Here is the smart contract. We can see different bids. This is the first bid. This is the second bid. We are going to make bid number 3 because the smart contract is already running. I can't start a new one until this one, the deadline is gone. But we can start a new one. But let us do another bid. Right. On this one, it tells me that, let me go through this. Or should I start in the beginning so that you see a new smart contract? Yeah. Before we start a new smart contract, let's test that we can add a third bit here. Now the last bit is 2 header, 2 header there. I can't bid here. You see a new bid amount must be greater than previous bid highest amount. You see now it already knows the new bid, which is 2, and it knows the previous one. We can even make it more clearer to the user. You see here, our new bid is 2, previous bid is 2. We can add this and make it more clearer here. But let me not code because I'll introduce bugs. So let me do a different bit. Currently now, this demo is using one wallet address to do several different bids. When I test it with a different wallet address, let me show you. There is a bug. I'm going to change the wallet address from wallet 3 to wallet 1. Then let me test. You can see here the new bidder now is starting from 65.9A, ending D50. 60.50. This is the new bidder. If you ask me how do I know this is the new bidder, you open your wallet here. You take the receiving address. You see this address. You convert it to pub key hash. Those CLI tools, you remember those CLI tools? When you convert this to pub key hash, then it is going to be what you see this, that string. You take this, convert it back to page 32. It will be this. How do you know I'm telling the truth? We can use Gimbat profiling here to do that. So we can walk through, look at what is the address here. This is the address. This address that you see here is this one, 659 D50. I didn't show the page 32 address here, but I'm showing the pub key hash, which is this one here. You see D50. We can show the pub key hash. Let's show the pub key hash. This one is easy. Right, on our new bid, we have got the address here. Okay, now how do we convert this to page 32? Yeah, let me look for the code where we show it as page 32. We have got a converter, I think, here. Pub key hash to page 32. I've got this one here, base address. And then this one, I think this one is the address function. Let's check how it works. Okay, this one, it gives us the short address function. Yeah. And then once we once we have an address, there is a function called vxsa. There are two ways for me to show you the correct address. Either I call this address function here, or I convert the existing address to page 32. So let me do one of these. You can see the page 32 as well as the pub key hash. When you are explaining, you need to explain what is a pub key hash. It is a hash of a page 32 address, or the hash of the address. What is a page 32? It is a human readable wallet address. Let me show you here. Here we have got a what? A wallet address. So now this wallet address, let's convert it to a page human readable address. I'll call it human readable address. Then we are going to call base address dot to page 32. It's a function. Let's JLog it. Let's see it. Right, let's look for the human readable logged address. Let's go there. There it is. You see the human readable address. Look at it. It ends with PSFXL. It is exactly this one here. There. That is why I said, because I asked you a question. How do you know this one is a new address? It's not this old address. So I've put this line for you to see I'm changing wallets, simulating changing people who are PD. If I change a code to 0, which is another account, this one is got JLE, 9 JLE. So when I reload my auction, then you'll see this now is a different person. 87E. If you come here, you see this is a separate person. If you want to see that this is this 87E, which ends 39F, here it is. You click the hex part. You see, there it is. This is 708. Sorry, man. This is the hex. We need the pub key hash hex, which is this one here. You see, it ends 439F. 439F. So this is a new beta. That is all what I wanted you to explain. So the most important part in your explanation, you cannot leave out these things. If you leave out betas, addresses, pub key hash, and then page 32. So an address is a byte. You need to explain address in terms of how many bytes is it. It has 57 bytes. This is bytes. It's a list of, it's binary, 57. And then let's compare it to the pub key hash. The format of this address in a pub key hash, it's a hashed. There's 28 bytes. Then the page 32, this one is a text. But this text has got this string. How long is the text? Let me count here. Count string. How long is the page 32? Without spaces, it is 63. So the page 32 is 63. There we have it. It has 63 characters. Let me write it down. So you need to check that all page 32 addresses have 63 characters. Let me select another wallet. We count how long it is. This is another one. Hey, the lengths are different. I think this one is longer. They are different. That's interesting. This one is 108. This one is 108. So I'm having different. I thought they were the same length. They are different lengths. Very interesting. Very interesting. Okay, let me get a third one. Which is the one that we are going to use for PT. It's 108. You can see this one. Why is the first one shorter? Maybe I made a mistake. Let me go back to the first one. Maybe I didn't copy it correctly. I think so. Let me try again. Yeah. I think I didn't copy it correctly. Yeah. I think so. I did cut it. So now we know the length of a page 32 address is 108. We finally confirm it. Yeah, 108. Okay, I will stop here a little bit. Ask you some questions. How long is a Cardano wallet address on Helios? How many bytes?
57 bytes.
How many bytes is pubkey hash?
28.
Bytes, not characters. And then the page 32,
It was 108 characters.
yes, alpha numeric characters. That is what you need to put in your what? In your explanation, because people need to know these things here. Now, let's get on with the testing. So I'm going to switch back. So the previous bit and this one are different. So I'm going to use the one I was using before, which is this one. So when I reload, you're going to see the previous beta is the same pubkey hash with me, the beta, because I'm the one who started it for this demo. If I use a different one, it doesn't work. There is a bug that must be fixed. Let's start with a different one here, which is this one here. I'm going to say 3 header. Then you need also to explain 1 million loveless equals 1 header. Okay, now the app is showing header in loveless. Why? Because on the blockchain, there is no header on the blockchain. If you check on the blockchain inside, there is only loveless. You are going to see that. But let's test this one here. Yeah. What I want you to see here, I'm using a different address. I'm using a different wallet address. This fails. But the very fact that it failed it gives us an opportunity to inspect the test, these logs, the J logs, to see why it failed and where it failed. This is important because you will need to explain and give this code for your technical documentation. We have got 4 rules. The first rule is this one here. I numbered it, number 1. What does this say? This one says the value logged by the validator hash. Validator hash is another word for script hash. Here I said the script address. Remember, validator hash is one thing. Sometimes they call it validator hash. Sometimes they call it script address. It's one and the same thing. Or sometimes they call it script hash. It is a hash of the script. So let's go through this part here. So number 1 is this one here, which checks that there is one NFT. in the validator hash. Second one checks that the value sent to the highest bidder, the loveless part, is equal to is equal or greater than the previous highest bidder. You have to refund the previous bidder if you are the new bidder. Number three, it checks that the auction is running before the deadline. So this auction is going to take 1 day. I have made them 1 day, 1 day, 1 day, 1 day. And then number four, the last one is this one here. It checks that the validator hash loveless is greater or equal to the minimum bid. There is a minimum bid. So when I'm bidding, I must make sure that this is greater than the minimum bid. Let me ask you one question. How can a hacker hack this to steal the NFT without paying? How can they do it?
I don't think they can't. I don't think they can.
Let's suppose these rules were not there. Anyone can send a transaction and then the transaction runs, then collect NFT without paying. Does this force any bidder to pay first before they get the NFT? If it does, where does it force them? Here, number two. When you are running your transaction to bid, the loveless you are sending must be greater or equal to the datum highest bid. The datum highest bid is the previous bidder. If you are bidder number two, it is bidder number one. I explained to this in this A, 3 header. Then A becomes previous bidder for B. Bidder bids 4 header. And then the previous bidder becomes A, and the previous highest bid amount is 3 header. I think this makes it clear. Let me give you this. You will need to explain this again. But what is missing on this one is the off-chain. That is the on-chain part. There's a mistake there on this diagram. What I listed there is the on-chain. This box which is empty is for the off-chain transactions. I think I'll give you this once we have filled that part. Okay. The purpose here is to check that no one can take the NFT without paying for it. So this forces any bidder must lose money to the smart contract before he or she gets the NFT. So you put your money there onto the marketplace. B is going to bid with 4 Ether. Okay, but does B get the NFT and lose the Ether? If yes, then B can walk away. Then there are only 2 people to bid. When they have more than 2, then the deadline is useless. That is why when we open the deadline, B is going to send his or her money to the smart contract where there is the NFT. Another possibility is the first bidder can send in 3 Ether to the smart contract without the NFT. So when the second bidder comes, you are bidding for an NFT that does not exist. How does this smart contract prevent that? Did you get my question?
No, can you repeat the question?
My question is, the auction is starting. The first bidder, who is the owner of the smart contract, can create a smart contract but fails to put the NFT. Then people come and bid for an NFT that does not exist. How does the smart contract prevent that? Are we able to prevent that?
I think the smart contract locks the bid.
Let's look at our transaction here. Do you see here this first rule number 1?
Yes.
It says what? Value locked by the validator. The validator is the script. This means the NFT. There must be at least one. There must be one NFT. If this doesn't find an NFT on the smart contract, transaction fails. Nothing happens. The smart contract for auction is not created. Are you getting it? So this number 1 is a rule that prevents even the first owner to make sure that for the transaction to run, there is an NFT, this one.
So they can't run it without anything.
No, you can't.
It's,
If you run this transaction and you do not attach the NFT, it is not going to run because this is going to fail. Here is an example of chain code. When we are building the output, so we are here now. For the first one is this one here. But this is the output for the first bidder. This is the person who is creating the smart contract on auction. Is going to run one transaction. And what is this transaction? Transaction output. Here it is. And then what does it have? This is the place where you are going to lock your NFT. Where is this? This is the script address. This is the NFT you are locking. This is the NFT you are locking. Now, let us look at this NFT clearly. This is the information about the smart contract. This information in line that is this seller up till here. It is this information we have here. The tattoo, seller bid asset. You see, this bid asset is the NFT. Also, the seller value here must have the NFT. Deadline, highest bid, highest bidder. Okay, let's go back here. Where was I? Yeah. Done with that one. Yeah. Let's go to the off-chain part. So this is the one that I was showing you here. So if you go to this one here for sell, let me show you where we are building this for sale. We are building it here. When I click this button, start auction, here, I build and send the NFT. Here it is here. Here is the NFT. I'm going to send the NFT. This one. I want you to see. This is the NFT. This is the name of the NFT. This is the ID, which we call policy ID of the NFT. I have to put it. But remember, I can put null here and let this go. It will fail. Why? Because this side, it wants the NFT to be locked. That is number one. So which means we have built it correctly, forcing the first person to send in the NFT and the 3-header. What about, can the first person send NFT without 3-header? Let's check our transaction output. Yes, they can do that. And the smart contract is going to run. This is a loophole. This is a loophole. Means I didn't think it correct. If you want to see, this can run. If I take out the, where am I building it? If I take out the money, this one, the money, it will run. All right, let me check here. This one here, the value for sale. See here, value for sale is nothing. It is empty. It's not created here. Value for sale. Let me go up to the bid. I am creating the value for sale here. Number 89. How am I creating it? I'm adding the minimum bid, that money for starting, which is starting here. But I can put 0 here. It will run. There is the asset, which is the NFT. This is the NFT. I can put 0 here. It will run. I can remove this. It will run. Right, let's go to our auction. So we need another rule that will check that there is a minimum bid. Yeah, there is the rule. There is a rule. But this rule is for the bidder or the first bid, yes. You see here, the B bid means, yeah, this one forces a person to lock the NFT with the first bid. This forces that 3-header. Because if now the validator hash does not have a loveless sent to it, which is greater or equal to minimum bid, then the transaction doesn't run. So the question is, yes, you are right. This cannot happen. A bid, whether the first or the second, must always have money. You must bid. Must bid. If there is no money here, you come here, you try to collect the NFT without sending money, it won't run. This is going to check that. So basically these 4, they are okay to get us going. We have to think more of other security issues. Now, I ran this, it failed. My bid failed. Let's check using this JLog. You see all these JLogs. They are here to help me know, trace, where did the logic go wrong for this 4 to fail. The nice part that I did here, I numbered my 4 logic rules. I numbered them, number 1, number 2, number 3, number 4. So if you check here, you follow them. Number 1, the rule passed. Number 2, the rule failed. So the value sent to the highest bidder, the Loveless, is not greater than the highest bid. This failed. And then this one also passed. And this one passed. So, you know what? I was thinking this thing is failing because the amount that is being sent, the address that is being used is wrong. Actually, I'm discovering now that here what is making it fail is a rule number 2. The value being sent to the highest bidder, the Loveless, is not equal to datum.highest bid. Why? Let me check here on my wallet to make sure that do I have that amount. Here I have a lot of test header. I've got 2,000. On this wallet you have 2,000. Then why did it fail? Why is it saying this TX get Loveless? The Loveless is not greater or equal to the previous highest bid. Now let us check it one by one. What is the datum.highest bid in this transaction? So we can go and check where we are having it. There it is. Datum.highest bid is what? 2 header. Okay. Next question is, what is this value sent to? This value sent to, here, get Loveless. Let's look for that. Here it says value sent to, this is datum. Here we just want value sent to. This one, value sent to. There it is. Haha, look at here. The value which is being sent to in this transaction to the highest bidder is a 0 Loveless. Okay. I think this one is the problem of the wallet. It's not the problem of the app. Because if you check the app here, the value, when I'm building this for the second bidder here, I have said minimum, send minimum bid. It said 0. That is very strange. Right. Here is the output to the previous bidder. Here is the output value. And look, the output value, I said, yeah, that thing is correct, Rito. You guys is correct. It is correct. It is correct. Here, I was trying to cheat to collect the NFT by only paying 2,000 instead of 2 million. Okay, so let's correct it. Remember, the previous bidder amount is the one that is needed there. So instead of putting 2000, let us take this one, the previous beta amount. Right, there we go. Got it. Right, this one is int data. What does it mean? It means it's already in a form of big int. Then what does it tell me? Tell me I can use it without converting it. I don't need to convert it here to big int. Let's test it like this. Very interesting. Let's test this like this. Or let me run it. I'm using a different wallet, which is what is supposed to happen. So let me select 3. Let's do a bid. It is saying cannot convert undefined to a big int. Okay. Why does it call it undefined? I want an answer. Let me see. Rido, are you with me? Sorry, maybe you are tired. When you are tired, tell me.
Yeah, I'm with you, sir.
You are with me. Answer my
Yeah.
question. I did put here previous 3 high beta amount. You see it here is 2 million. But why is it saying on the other side it is undefined? Why is it saying it is undefined? It is saying it is undefined because I did not say dot value. I did not say dot value or dot int. I can say dot int. Let's try that. We will need to explain that on the technical documentation. See here I say dot int. The most important thing, let's run it. Okay, going to reload. And I'm going to beat with a 3. It fails. It fails. Let's look. Number 1 passes. Number 2 fails. You see, this number 2, it fails again. Now let's find out how much is this. Get Loveless. Fails here. It is saying 0. This value sent to Get Loveless. It is saying 0. Why? We need to find out. I have got this here. Now let us check this output. We are going to go to this output value and check the value part, the Loveless part. Right, let's check here. What is the output? Loveless. See, there is the Loveless. 2000. Let's check the NFT. There is no NFT. Yeah, that is why it failed. There is no NFT. There is no NFT. That's why it failed. But I said get Loveless. It was supposed to give me this, but the NFT is empty. Let us check here. Yes, I removed the NFT. So I need to add the NFT here. This one here. Very interesting. Okay, let's try again. Just wish it can run. Then it will be a real. And let's try again. Let's go. There we go. It says non-positive amount. Right. I think we have met this non-positive amount before. Now I need an answer from you. What does this non-positive amount mean? We have met it before, and I explained it, what it means. Hello, are you there? Let me check. You're online.
Yes, I'm there.
What is the non-positive amount referring to?
Maybe it's because I'm not really sure.
Let us check. On this wallet that I selected,
Yeah,
which
I can't see.
NF? You can see.
Yeah, I can see you sharing your screen, but it's blank.
It's blank. So let me share again. Can you see now the wallet?
Yes, sir.
Let's count the FTs. We have got 87, 82, 85, 86, 84. Which one are we selling? Remember, this is a person who is coming to bid. But which one is being sold? 87, 82, 85, 86, 84. How do we get to know which one is being sold? Check the policy 678. Check. But for you to know which one is being sold, on this one here, we have the NFT, which we are selling here. Which one is it? Where is the NFT you are bidding for? There is a mistake there. We need to give to the person NFT so that I know which NFT am I buying. Currently now, for me to know the NFT, I have to go here to the script address. Right, where is the NFT that I am buying here? Because when it says non-positive amount, I suspect it is saying there's no NFT. This is the transaction detail. The NFT is 93. It is on this wallet address. Yeah, it is this one, 93. Do we have 93? Yes. We have 87, 82, 85, 86, 84. I think I've given you the answer.
No, there's no 93.
Yes. This means there is no FT fungible token or non-fungible token which is being locked, non-positive amount. So I have given it an NFT to lock, but I don't have it on my wallet. Then my question is, then why are we locking that NFT? Maybe it's written, it's needed today. Which means people who bid are those who have this NFT before. This is a very wrong thing. It's completely wrong. I am bidding for this NFT. Now I must have it on my wallet. Doesn't make sense. It does not make sense. This rule maybe does not make sense here. That I must send an NFT. Doesn't make sense. This must check that the locked value is that NFT. Yeah, this rule I think is wrong. Rule number 1 is wrong. Get Loveless. I think that is the wrong rule. Okay. What I'm going to suggest we do is let's remove that rule number 1. Because this is a new person who is bidding for the NFT. And the rule is saying that NFT must be there on my wallet. Then why am I bidding for it if I have it? Doesn't make sense to me. Let's check again. What does this say? It says value locked by. If I look for this NFT, the NFT must be there. This is okay for the first bidder. But for the next coming bidder, it is not okay. Because I am bidding for that NFT. I want to buy it. Why must I have it on my wallet? This is a bug. I found this on Helios book. Let's check it on Helios book. I think from my part doesn't make sense. Here it checks the deadline. Value sent to the bidder. Okay, this one is okay. Value locked by datum. For sale. It has got this for sale plus this. Value locked by datum. There are only 3. I made a mistake. I added that number 3. expected datum. You see this expected datum. It is updating my bid here. At the same time, it is creating a new value, getting bid asset from the datum. Okay, I think what we can do, we can put this back. I removed it. And replace what we have here. Here we have got value locked by datum. What I'm trying to fix here is this auction works if, for example, I use one wallet for bidding several bids. But a real bid auction, bidding in an auction, you have got different wallets bidding. So we need different wallets to bid, not the same wallet.
So you can't bid using the same wallet.
I can. If I'm using the same wallet, it works. So here I've reverted back to the previous wallet. So you're going to see current highest bidder, new bidder being the same pubkey hash. Do you see now? I've got 89BE, 89BE. I'm the same person. But when I do a second bid, it works. Let's run it. You see, perfect. It works. Why? Because that non-positive amount is come true. Now, if you look at number 1 here, it is true. Number 2, it is true. If you look at here, where I said the highest bid, it has given everything, okay. Value locked by, value sent to. Where is that value sent to? There it is. Now it's working fine. It has shown the Loveless is there. And then let's get that value sent to. Let's get the asset. Uh, this one is what is going to be sent to the highest bidder. And it's the same amount I'm going to lock again. Value locked by datum. I don't have that datum. I didn't put that. Datum dot bid asset is this one. There's something I want to see there. Value locked by. It's true. I want to see. Do I get, yeah, this one here. Value locked by validator hash. Get this bid asset, this one. Yes, there is one NFT. So you can see it's working fine. Let me sign it, you see, it will run. It is already running here. Let me close it. Running, sign it again. So you see it's working. So if we go to our auction here, we are going to see a third bid, which is 3 Ether. So we are going to see another UTXO. Now, what I want you to do is to explain also the components of a UTXO. So I will add it here. For your technical documentation, definitely you need to explain this part here. UTXO is a hash, is an index, is a value. And the value has got what? Has got loveless. So on chain, you see loveless only. And then it has got one asset. It has assets. Here in this case, it says one. A is that NFT. This is the NFT policy ID. This is the NFT name. It is in a hex. If you convert it to text, it will actually tell you the correct name. That is very important to explain because people need to know what are these numbers for. If we say hex to text, if we use our command line tool, it should work. If I use this converter for hex to text, it should work. There it is. Do you see? There is the name. 1893 share FT. Okay. So now I'm going to reload this. Things where I must see 3 UTXOs. There are 3 now. You see now here is a 3rd bit coming to the same smart address. It's coming now to the same smart address. So let me copy all this and give it to you. You will be able to explain this for the technical documentation. For the users don't even need to know about these things. They only need to know how do I bid, how do I create my first auction so that people they bid. That is all what they want. So okay, this shows this auction is working, but it's only working with one wallet. Now I'm going to change it a bit, take out this rule for now. Going to change it, take out that rule. Leave here that the previous bidder must be paid this month, otherwise no one is going to join the auction. The deadline must be before the deadline. And then the other thing is I must put in a money for bidding which is greater than the previous bidder. To me, this now looks like it's forcing me, my wallet, to have the previous, to have the NFT that I'm bidding for. I don't know how we can change it. We can try 2 things. We take this one out, we replace it with this one. We replace it with this. I will explain this. First, let me take out the comments. Right, I'm going to test number 5 here. Actually, number 5 now becomes number 1. If there is something you don't understand, ask, because I'm here and I've said you must be here so that I explain. I'm expecting when you give me that document, it must be at least 40% better so that I can add the other things. If you see anything you don't understand, and keep quiet, and then later on you have to redo it. That's a challenge. Okay, this one now, we are looking at this datum, expected datum. We create it here. So this expected datum, we are using this function datum.update, which is this one here. We update the datum with a new bidder, and then with the new bid, which is my bid. And then we check that the value for sale plus this value is true. This one, there are two things here. Now, how do I test this on J? Because I need to test it so that I know if it says false, I must know exactly what is false about this. But I'm going to test it twice. Right, the first test, let us take this part here. What does this value log by datum, expected datum, contain? Here we have it. This will tell me what does the new expected datum value contain. Right, the next one, I will call this 1A, 1B. Does it contain here datum for sale plus this? What is this? We are adding two values there. We are adding this datum for sale. Where are we testing it? Right. This is we need to test now this on its own. That becomes our B. Got it? Right. That 1B is going to tell us this datum for sale. What is inside? And let's have 1C. The 1C, we want to see what is this value like. I think I have this value. Yes, I have it. There. I'm testing it already here. Let's move it down. Then it becomes C. There is some mistakes here, serious mistakes. Get Loveless, this is okay. This one's a serious mistake. We need to return a value. Okay. And then this one here also datum dot for sale. It is value, not book. And then this one also value, new value. We've got this datum dot bid asset and then the bid. Right. Now, the next thing, the last thing we need to see is this going to be true or false? This whole line. So if it becomes false, then we have to check ABC. Where is it false? Right, so this is 1C. Okay, so one good thing here is the moment you change your smart contract, your script address changes. Then the whole auction changes. The old one falls away because it is a different auction now. Want to see I've changed 1C, 1D. Right. If there is an error, it's going to show me the error. I just forget anything, it's going to show me. Right, let me run it. Now you will see this is what you need to explain. When I run now, the script address has changed. It is no longer this auction. It is going to be a new auction. Because it's a new auction, this app immediately is going to switch. It will close this one and then switch to the form where I create a new one. Let me run it. There are bugs on the on-chain to 254 type error. Expected 3 arguments got 254. Yeah. Yes, the moment you call this value dash underscore locked underscore by underscore data, you must give it 3 parameters. Datum text true. Is it in line or not in line? This true means it is in line. Okay, let's test again. So this 254 must change. 266 now. There's another bug on 266 here, which is this one. 266. But what is it saying on 266? Also expected 3 arguments. Right, I've got locked by datum. Yes, the datum there must have true. So 266 must disappear now. There's still the expected 3 arguments go 2. Let's check again on 266. Yes. Change datum, the value locked by datum. Oh. Remember here, value locked by datum needs a true here. Right, now we go to 252. Expected datum already defined. 252, yeah, this one. It is already defined here and used there. So I don't need to define this. Cool. And then the other most important thing you need to see here is Helios makes working with on-chain and off-chain simple because I'm working on one project. If it was ICANN, you will do ICANN separate on a different project. Compile it, make it okay. Then you go and do Lucid evolution on a separate project. Then you are going to suffer from what we call integration end-to-end testing. This one you can see I'm debugging the on-chain this side, but I'm getting the results on the off-chain front side. This works beautifully with the JLog. But let's hear what other developers are going to say. Right here, 258, reference error, datum.tx undefined. And 258, there's a typo error there. Here. 258 here. The error is here. And this one true. And then contains that one for say, comma that. Yeah, that was the error there. Of course, this one needs to have this. Right, what I was telling you is what you see now. Do you see the app has switched me from the old auction into the new auction?
Yes.
Hello?
Yes.
If you want me to show you clearly, let me show both the old and new auctions. I'll show both. This is the old auction. Now the code is going to prevent this. To prevent it. Where does it switch? Here. Do you see here? It detects the deadline here. Also here. This one, it detects here that this is an old thing. I comment out this. Also here, it detects that now the deadline is still okay, but now the problem that is there here, it was detecting that the script address has changed. So let me run it and see. Cannot read properties of undefined because of this. All right, let me leave it like that. But exactly what I want to tell you is exactly what has happened. If the deadline passes, immediately the script on its own will switch and close the old auction, which is good. If the script changes, like in this case, we have changed the script, immediately it detects. You can see here, see this, it fails. And then down here it says script was not found. Then here it tells you TX input from block frost did not find UTXOs. Then it immediately takes you to create a new auction, which is exactly what we want to do to check we can use a different wallet. Right. Right. Let us mint a new, actually, let's create a new auction. This time, the auction I'm going to create is going to be in line with this. Start with 3 header, 4 header, 5 header, and see it's going to run. Right. We are going to select any, it doesn't matter, 93. And then we are going to change this to 3 header. And then the deadline tomorrow, 25. Let's start our auction. Okay, there we have, see now it's 3. Why? Because this one, this asset here, see, this is, I'm locking 2 things. I'm locking the smart contract onto the smart contract, 3 header and 1 asset. Let's proceed. Okay. Now, from my machine, when I reload now, it is going to detect that there is now a smart contract that is there. And that smart contract below here, where there was that submit button, it is showing the transaction ID of the new smart contract, auction smart contract that is running, which is BD293. I don't need to click this to see it. The details are going to be shown when I reload. Do you see now? So what do you see?
Yeah, I see it.
What do you see?
What do I see?
What has happened? What has happened?
Gary, you created a new auction.
Correct. Now, there's something that happened I wanted you to see. I don't know if you saw it. When I reloaded page, what happened? Did I create that auction on this tab, on this page?
No,
I created it
on
here.
this one. Yes.
Yes. Finished with it. Then I reloaded the page. Then what happened?
No, I didn't saw that.
What do you see now?
I can see that it has picked the new bidder here.
Correct. It has picked a new bidder. Okay.
Yes, and it's saying the current highest bidder is the same as the new bidder.
Correct.
Yeah.
What
And
else is it picked up?
sorry?
What else is this app picked up?
The date.
Okay. What else? So something more
Script.
important that I want you to, because if you don't see it, you won't write it on your technical documentation.
I think the script address is also you.
Correct. Therefore, this is a what? A new auction. This is a completely new auction.
Yes.
Right. This is the old auction. Let me close this. Close this. But I'll leave that. Do you see this is the old auction? I'm going to
Yes.
old auction here. And when I run the old auction, it still shows how many bids were done.
3.
3. Which one was the last bid?
3,000 3 million lovelies.
Yes, 3 ADA. This was the first bid, second bid, third bid. On this smart contract, auction smart contract. Perfect. What will happen now when I click this green button? What are you going to see?
Is it going to take you to that page?
I'm asking you, what do you think?
I think it will take you to the same page as that, the one you are showing now, which has the bids.
Why do you think that way?
Sir,
Why do you think that way?
I'm just guessing, sir.
All right, good. You're telling me the truth. Let me save this picture here. I think we are going to need these pictures here. This one is not Bluetooth. It is Helios. I don't know where to save this Helios part. Yeah, there we go. Because you will need these pictures, I'm telling you. I've taken that picture. Here. Yeah, I've taken this old picture of the old auction. Now I'm going to click this. What do you see here? Let me click here. Where are we?
Okay, so I can only see one. I can only see one bid, the 381, because
Indicating what?
as the
What can you say?
it is the previous one you did, the first one you did,
Compare now.
which
This
means
one, compare this. What you see here. Here.
on okay on this one, the one you did first is 3 million lovelies, 3 ADA, and then on the other one, the first one you did is 1,900,000, and yeah, that one,
Here is a
the one
clue.
which has
I want you to look at this. Here is a clue. Look at actually
the
the last.
other.
See this one, 87 SDS. Look
Yes,
at it. Here is a clue. What do you see here?
this one is other wallet address. is different from that one. I
Right.
think
Is
it's because
a wallet address? No. This is a script address. You won't find it on the wallet because remember, this this is the script address. Okay, let me go back here. I came here by clicking, then it didn't open a new tab. It replaced the old tab. But I'm on this one here now. I want you to see the script address. You normally see it, it's a long thing. You see a F2G. It is the human readable. This one. You see this one. It is not that one. This one is the one which is from the wallet, which is me here. But that one, that is the script address. It is this one here. Here, it is this one, the script address, which is this one here on the green bar, that green button. Okay, let me tell you what is happening here. This is the old auction with a different script address. So if you use this script address, you get to the old auction where there were 3 bids done in 3 different transactions. See those 3 UTXOs. We started a new auction first by changing the script address. Once you change the script code here, immediately the script address changes. Then you are forced to start a new auction with a new script address, which when you click this green now, we have got a new auction now. We are on a new auction now. This is the first bid, which is this one here, that yellow line, 3 ADA and the NFT. Now, where is the NFT? NFT is this one here. Do you see this long string here? 55CO ends with 654. That is the policy ID of the NFT we are auctioning on this new auction using this new script address. Now, if you want to see, you can click here to see more details about this NFT. If you want to see the data or the information about this new NFT, you have to click this part here. This one here. We call it extra information or datum or data or datum. I'll click on it. You are going to see we have got there is the 3 data, and then there is tomorrow. That is the deadline is tomorrow. There is the first bid. Our first highest bid is this one. Who has done this first highest bid? It is this one, the highest bidder. These numbers you see here are converted into hexadecimal. Right, I've explained that part. If you don't understand it, you'll need to practice it and practice it and practice it. Now, right, let us do a second bid. This time, remember what we want. We want to use a different wallet and see if we are going to pass. We can pass using a different wallet. I can tell you I'm going to be happy. If you remember the change that I did, there is no, here there is no 83. There's no 93 here. Good. Remember the change we did here. The change we did here, we blocked this one. This one required us to have that NFT for us to bid. Why should we have that NFT on our wallet to bid when we want that NFT? If I have it on my wallet, then I won't lose Ether bidding for it. That is what the change I did. Let's run it. If it fails, I've got extra Jimba logs to give us information about what is failing, where is it failing. Okay, let's start. My prayer, I wish it to work. Then we have a real auction. Right now, we can't use 3 because 3 is the highest bid. Let's go to 4. And we follow this. B, we are B now. And remember, B now is a different wallet. I've switched from 3 to 1. Okay, let me run it. All right, let's put 3. Submit a new bid. All right, what does it say? Okay, I need to make this 4. Submit a new bid. Non-positive amounts again. That error again comes back. I change the wallet, then this non-positive amount comes back again on the new bid. Oh, I'm devastated. Let's check why again we are getting this error. This is the non-positive amount error again we had before. Let's go back to our wallet and inspect. We'll go to another one, this one here. Everything here is okay. Everything is okay. Input is okay. With our TX input, the minimum bid says non-positive amount. If we go through this debugging tool to find out what positive amounts is it looking for, balance assets. The assets are not balancing. Let me check one thing on our there's a failure here. Last element. This one is okay. Why did this transaction fail? Let's look at the highest bidder value. Value here. Yes, there is something there. The highest bidder, we've got that stuff there. Script output value. Assets 2. Yeah, they're there. And then Lovelace is there. And then this one, Lovelace is there. Script output B. There is, remember, there is output B. Assets there. Value, Lovelace there. So the non-positive amount check here. TX output, go to value, assets 2, they are there. Lovelace is there. Assets, it is there. Okay, let me go to another wallet. If you look at this error before I go to another wallet, it is on the off-chain part. It is on the off-chain part. It's not on the on-chain part. So there's no need to go to the on-chain part. How long is it going to take me to follow through here? Let's try to use the debugger because the problem is on the on-chain, off-chain part. Let's step into code. And then let's step out, analyze, fail. Step into this move. It does it crash. Balance, yeah. Some things are not balancing. Balance assets. Let's go again. And then just move to the net part balance. Let's go inside. Right, balance assets. Our assets are not balanced. Some output assets must be equal to the inputs. This FN some output assets. Let's check here. Assets. Then loveless 0. Why is this loveless 0 here? Very strange. Let me move. Yeah, there it is. There is a 0 loveless. N is greater or equal to error, not enough input assets. If config max assets per change output, new config okay. Let the number continue asset is equal to 0. Maintain policies for each tokens is fail. What does it mean? Config. What is this config? There is a certain rule for balancing your transactions that is broken here. If it takes too long, then I will cut. I think we've taken too long. But let me test again. Don't need this one now. We don't need this one now. Right. Let's go to the config. Right, the configuration, auto set validity range false, check cast false, debug false, test true. Dummy inputs 2, strict garbage false. Dummy inputs 2. Maximum assets per change output undefined. That is what maybe is causing the problem. Max assets per change output. Max assets per change output. And then this one fails. You see? So this one fails, then we come here. And then definitely here there's a problem. Okay. And we've got our text output. Transaction output. Datum. There is no datum. No transaction. There is no datum. Why is there no datum? The address is there. Why is there no datum? Value. Loveless is 0. This is a problem again. There's a 0 loveless here. A 0 loveless. Let's check the transaction output here on the new bit. If I fail to locate it very quickly, then we call it a day. Then you go and finish this thing here. New bit. Let's check the output script. Value. This one has got inline datum. And then the provider inline datum. Maximum. Okay, yes, I see. And there's the asset. All right. Let me go back to the wallet that works. It's a small problem, this one. I can foresee it. It's a small problem. Let me run now this other wallet. Right, let's check here under go inside. We still face the same problem. See, this one doesn't crash. You see, this one is okay. Balance inputs. Everything balanced. Okay, I will need to give myself time to check why these other wallets are not working. What is it they don't have that makes this thing fail? Here I've got 3 assets. It's R. It's 3 assets. Number 3 assets. Config. So that config again, the undefined is the a valid range and offset. Let's move to the next part. Yeah, this one here. Transaction output. And then the value is still 0 there. Let's go inside. Let's get a breakpoint here. Okay, leave it to me. I'll sort out this one because can take a long time the moment you're checking.
Can you please send the notes you were writing down?
Yeah, I'll send you the notes that I'm writing down. Let me remove this. If we proceed and test, yeah, this is what I want to see. Let me run it till the end. Remember, we changed the script code there. Let's see if the on-chain part can give us some problems. Good. This can also help me see where things are failing. Let's start with our 1A. Value locked by datum. Nothing. See, there's nothing here. Value locked by datum, there is nothing. Then here, datum for sale, loveless, in this, correct? Then C, value plus that, of course, you're going to have that for header plus that. We can add datum for sale in this. D, value locked by datum, data hash. This one is the one that failed, that fails. Value locked by datum, data hash, contains datum for sale plus new value is false. This is what fails. 1D fails. What makes it fail? Datum for sale. We have that. Oh, I see why this fails. Oh, I see. Because you see here datum for sale. If we look at datum for sale, it has 3 header. We are adding this to a new value, bid asset, plus a new bid. The new bid is 4 header. But this logic is very complicated. We just picked up from Helios. It's very complicated. So it still fails here. So we cannot proceed with this one. Okay. So what is the solution? Then the solution I can try for the last time before we go is let's take out this completely. And then let's work with 3 rules. That one I will need to give myself time because we simply picked it from the book. But it is helping us understand this. Is this not helping you understand this thing deeper?
Yes, I'm getting closer.
Yeah, it's helping me a lot.
Yeah.
Okay, so now what do you expect me to do? I have removed this. So now we've got 3 conditions. This one, this one, this one. When I reload here, what do you expect to happen? This is our last round of test. What do you expect to happen if I run this? There's something very important I want you to take note of. The script address is going to change because we've changed the script. The validator hash of the script is going to change. Therefore, it will no longer be this option. It will no longer be this option. It will be a completely new option. Therefore, the app is going to switch automatically for us to start a new option. Do you see that?
Yes.
If I go back, reverse the changes that I did, it will resort back to the old script address, and then it will pick it up from the on-chain. Then it will still keep us on the old auction. This is the old auction. That is very important because it means once you deploy it onto the blockchain, no one can change the script and get the same auction. So a hacker is not able to go and tamper around with the script, hoping to get back this old auction to take advantage of that. The moment they change the script, it's a different hash, it's a different auction altogether. That is the security of the blockchain. So this is pushing me to a new auction altogether. Right now you can see this keeps decreasing. Now we are on 85. So I take one more, we'll go on to 84. Let's start with 3. Let's see. This is our last round of test. Again, remember now I've created a new smart contract auction, smart contract on chain on the pre-production testnet. I hope it's mined. When I reload, it is mined, and then we get is a new. Let me right click on this. Oh, now we have a new auction on the Cardano blockchain. Right, I'm going to copy the new auction, which is this one here. There's a new script address, you see. So I'll put it right at the end. And here I'll go back to this one. Right, what I have done here, I've done the A with a 3-ADA with an NFT. This is the 3-ADA with 1 NFT. There is our new information there too. Now I will move and do B. I'm going to try again. This time, remember, we have 3 rules now. We are no longer working on 4 rules. 3 rules. What I'm going to do, I'm going to test if I can submit for ADA. Number 1, using the same script, this one here. Let us observe here as we develop. Let me remove all the debugging information. Right, so I'm still using the same wallet. Let's select 4. Just want to see. It's running, okay? Those 3 rules are okay. But is it going to run if I switch the wallet? You can see this one is false. That is the one that I took out. Let's go and get the wallet. If it runs, then the next question is it not going to be hacked if it runs? Let's check. Because right now we are relying on 3 rules. We are relying for the deadline, which is okay. We are relying on paying the previous bidder. We are relying on a value locked get loveless is equal to the new bid. And then this one here is a paying back the other bidder. Okay, let's test and see. This time we give it 4. Let me change to 1. Yeah, I've changed this side. Let me start a new bid. Non-positive amount detected. Okay, that error. So that error has nothing to do with that. Non-positive amounts detected. But we are getting closer and closer to finding out what this non-positive amount is all about. Let me change to another wallet. Let's go again, non-positive amount. All right, no problem. I've narrowed down to an area where I'll give myself time to get why when we change wallets, we get this non-positive amount. This is a Helios bar. Remember last time I said we must find errors like this. Error reporting is useless. It's not helping us know quickly what is wrong. If you just say non-positive token amounts detected, where? What is causing that non-positive token amounts? It is token amounts. Definitely it has to do with the NFT. It's trying to detect this NFT on my wallet. But in this case, I'm not creating a new auction. The auction already exists. So on my new bid, one more check. On my new bid code here, this new bid code, am I using the old information here? Yes, I think that is the most wrong thing that I'm doing. This is wrong. I must use this information that is here. This one here that I'm finding from the here. Remember, the auction already exists. So it has already the NFT, everything here. Where is this thing there? This one here. So the NFT must come from here. It must not come from this saved wallet, must not come from the saved wallet. But will it make a difference? The only way I can know this thing makes a difference is to check this asset class. Data, asset class. Is to check it here. Where can I check it clearly? Non-positive amounts. Under in UTXO. Right, that wallet problem is caused by this one here. This is a different wallet. It comes from here. So it is caused by this input here. Okay, next, let's go back. When I'm creating the output transaction, not for the script, for the script, yeah, and for the script. This one here. This one, where is this coming from? See, it is coming from outside. Why can't we use, where is this asset class? Why can't we use this one here? This PHP asset. Let's compare this PHP asset class with the other asset class. We compare it with the datum, auction datum asset class. All right, quickly, what do we have here in the fields? All right, we have got these two. We've got these two. I'll only look at the hex 88FA. Okay, you see this 88FA. Then let us go and check that asset class which we are binding there. But when we start, we've got 88. Let me run it again. Yeah, there it is. It's correct. It's the same. 88. But I see here token name hex is undefined. Let's check the inline datum. This one here. X fields list inline datum. Let's check this one. That one is the pub key hash. The for sale asset is this one. Let's check the hex. Yeah, it's the same. It's the same. All right. Let's leave it like that. I've put it back to where it started now. Right, so we can't go to number 4 now. Right, we can. So what we are going to do now, I told you this is the last round. We are going to finish B, C, D. B, C. C is the last one with number 5. And then we are going to try D after B or after 5 to make sure that at least this is tested to that. This wallet issue of non-positive amount is a small issue. I'll have to go through it and know what is causing that. So for now, we are B. So imagine B, although it's the same person, another person is bidding with 4. What we want to see is, we want to see incremental bits here on the same script address. This script address ends with Luang, Luang. This is the first bit. Let's have the second bit, which is B, which is 4. Cool, it's working. Cool. There it is working. Beautiful. And then we can reload our UTXOs here. A couple of minutes. There we go. Look, there is our 4-bit. See, there is our 4-bit. So it means now our auction has been updated with the next bit here. If you look here, on this one here, I'm going to take a screenshot of this because I think you are going to need it. On this one, the last bit is 3 eta. The last highest bit is 3 eta. And the last beta is this 4-5, which is the same wallet I'm using. Don't worry about that. But the script address, what I want you to see is that script address remains the same as new bits go. So I'm going to save this one, give you these pictures. What I'm running away is, I give you the code, you try it, breaks, you fail even to set it up. Then you stop doing the documentation, which I badly need. So now I'm going to reload this. Now the beautiful thing, the thing you see here is the app now has got new bid information displayed to a new bidder. And now it is even setting up my first bid must be greater than 4. If I just click, immediately it tells you this must be greater than the previous bid, and the previous highest bid is 4 eta. According to that diagram, this part is working. It's exciting. This one is exciting. There it is. We have got the 4 now. It's purple, which is B. Now we are going to try to be D. Oh, no, we go to C now. C is going to bid 5. Let me reload. Five. We run 5. There, it accepts. And let's what I want you to see. All right, let's confirm. Oh, sorry. Okay, there it runs. So this is this bidder now, who is bidding with 5, is C. Now C is the last bidder. So if the deadline reached, then C needs to collect the NFT. There is one part that is missing here. We need to wait for the deadline. And once the deadline is reached, then C can now go to the smart contract and run a transaction to collect it. The problem with the smart contract is We leave it like this. In this case, if you see it from here, let's wait for the file. Right, let me reload here. 1AO. Yes, you see here, it has updated here. The last beta is now 5. This one is slow in updating. Come on. There it updates. So let me give you this information also. You'll need this. So I'll send you these pictures. And also copy this. This one now is showing the complete test. Let me add this here. Right, I've taken this picture. Now I need to take this picture here. The other picture that you need now, we go to our diagram, this one. We will need to update this so that when you add this, it makes sense. I'll correct this offline now. 4 comes and tries to be naughty to say, all right, for me, I'm going to beat with 4. Here. It's going to be kicked out right here. The validation immediately kicks 4 out here. But if on the front side, a hack is done on our on-chain part, it is not going to allow that here. This won't allow that. So it means now there are 2 things. Our auction can wait until the deadline finishes, or E comes with a 6 bid going forward. Then it will accept that. So this smart contract is working to a certain extent. Any question from you, Rito? Which other pictures do you need? I have taken the picture for this side for you to explain.
If I need anything, I'll tell you, sir.
Yes. From what I have set it up, it's working. I will copy. You see the nice thing of these FTPs? I can do it before you even close your eyes. So that if you want to test it on your own, you simply write this and step through from your own wallet. But I don't want you to tell me, say, there's a bug, this is not working. If you're using another wallet, it should still work. Maybe you do not have this test data. Do you have a lot of tokens to, like you see, I've got 200,000, keeps decreasing because I keep using them. If you do not have this, then you won't be able to run this. I'll be wasting my time. I'll rather give you this. You concentrate on building up the user manual. I'll also try to upload this video. What other picture do you need for this? I've taken this picture. I've taken this one here. I've taken this code. Maybe you will need the picture of the on-chain part here, the smart contract part. So for now, I'll leave these ones commented so that you explain what happens. I'll take this big picture of this. All right, that's enough from my side. I'm going to hand over this to you now. But the first thing is this. I will also save it on that same folder, Coxygen, universities, Bluetooth, Helios. So the name I will give this one is what? Report. This one is for the report. Okay. Yes, this is the one that I put here for you, the report. And close this. Tell me, what else do you need?
Nothing for now. If I need anything, I'll tell you.
Yeah. So produce 2 user manuals, one technical, one for the user, using the
Okay.
information that I have given. For the user, you don't need to go into the source code. The user won't need. The user only needs to know, how do I use this auction? So the user needs, okay, I have a wallet. So you need to have them that information about. Have your wallet, set it on pre-production, have test data, have some tokens to auction. That's all. Have some tokens to auction. And when you run this, you see that first one that says create an auction, a new auction. Then we explain that diagram. I need to update that diagram before I give you now. Where is the Helios? This one. Right. Okay, before I upload this, let me update this diagram very quickly. Scarlet Pro. Okay, let me upload the rest. This one, I'll send it to you later. So on Coxygen, we have got an upload. If I remember, we have got this upload. Okay, perfect. All right, I think we can stop recording for now. I have sent you the there we go. Send you the link where you download what you need. Okay, thank you very much.
Thank you, sir.
All right. If you need anything, let me know.
Yes, I will.
Okay.